Speed is the rate of change of distance with respect to time. It tells you how fast an object is traveling along a given path. Like distance, it is a scalar, meaning it has magnitude only. To calculate speed, the change in distance and the change in time must be known. Speed equals change in distance over change in time. In symbols, S equals d over t. In the illustration shown, Jen takes 8 seconds to move from point X to point Y along a path 40 meters long. The distance is the length of that path, 40 meters. So speed equals 40 meters divided by 8 seconds, which gives us 5 meters per second. Velocity is the rate of change of displacement with respect to time. It tells you how fast an object is traveling in a specified direction. Like displacement, it is a vector, meaning it has magnitude and direction. To calculate velocity, the change in displacement and the change in time must be known. Velocity equals change in displacement over change in time. In symbols, v equals x over t. In this illustration of Jen's motion from the previous example, we can analyze it for her velocity. The directed distance represented by the red arrow is the displacement. In this case, it is 24 meters towards y from x. So our velocity equals 24 meters divided by 8 seconds, which is 3 meters per second. An aeroplane flies with a constant speed of 200 meters per second along the path ABCD. While its speed is the same throughout the motion, its velocity is different for each section because the speed is in different directions. From A to B, its velocity is 200 meters per second east. From B to C, its velocity is 200 meters per second north. From C to D, its velocity is 200 meters per second west. And from D to A, its velocity is 200 meters per second south. So we have a case of the same speed but different velocities. Positive and negative signs are given the same treatment when dealing with velocity, just like displacement. They represent direction. In the illustration shown, both cars have the same speed but opposite velocities. The car headed to the right has a velocity of 20 meters per second, while the car headed to the left has a velocity of negative 20 meters per second. An object with a constant velocity travels with the same speed in the same direction. If any of these or both change, the velocity of the object changes. Worked example 1. Jane completes a 100-meter race in 12.5 seconds. Just after the race, she takes 2 minutes to walk back to the race starting position. Calculate A, her velocity during the race, B, her velocity when walking back to the starting point, C, her average velocity for her entire motion, and D, her average velocity for her entire motion. For her velocity during the race, we are going to take her displacement as 100 meters. So velocity equals 100 meters divided by 12.5 seconds, which will give us 80 meters per second. For her velocity when walking back to the starting position, we'll take her displacement as negative 100 meters, and the time, 2 minutes, will be converted to 120 seconds. So her velocity is negative 83.3 meters per second. Her average speed equals the total distance divided by the total time. So the total distance is 200 meters. The total time is 132.5 seconds. It will give you a speed of 1.5 meters per second. Her average velocity equals the total displacement over the total time. Total displacement is 0. So her average velocity is 0. Worked example 2. An object is traveling with a constant velocity of 20 meters per second. Calculate A, the distance it travels after 5 seconds. B, the time it takes to travel 180 meters. Part A. Velocity equals displacement over time. So 20 meters per second equals x over 5 seconds. Rearranging this and calculating, x equals 100 meters. But we know that distance is the magnitude of displacement. So distance equals 100 meters. In part B, 20 meters per second equals 180 meters divided by t. Rearranging this, we have t equals 180 meters over 20 meters per second. So t equals 9 seconds. Acceleration is the rate of change of velocity with respect to time. Just like velocity, it is a vector. Acceleration takes place whenever an object's velocity changes. Therefore, a change in direction or speed means that acceleration has taken place. To calculate acceleration, the change in velocity and change in time has to be known. The most common unit for acceleration is the meter per second squared. Acceleration equals change in velocity over change in time. In symbols, A equals V over T. For example, an object with a constant acceleration of 2 meters per second squared means that its velocity is changing by 2 meters per second every second. If it began with a speed of 10 meters per second and speeding up, it will have a speed of 12 meters per second after 1 second, 14 meters per second after 2 seconds, 16 meters per second after 3 seconds, etc. If it began with the speed of 10 meters per second and slowing down, it will have a speed of 8 meters per second after 1 second, 6 meters per second after 2 seconds, 4 meters per second after 3 seconds, etc. If an object is speeding up in the positive direction along a straight line, its acceleration will be positive. If an object is slowing down in the positive direction along a straight line, its acceleration will be negative. An object that is slowing down is said to be decelerating. For simplicity, we will be dealing with acceleration questions in the positive direction only. Worked example 3. Calculate the acceleration of a car that accelerates constantly from A. Rest to 40 meters per second in 10 seconds. B. 10 meters per second to 20 meters per second in 5 seconds. Part A. The word rest means the object was not moving before it began accelerating. So the change in velocity is 40 minus 0. So acceleration is equal to 40 divided by 10, which is 4 meters per second squared. Part B. Acceleration equals change in velocity. What is the change in velocity in this case? The change in velocity is 20 minus 10, which is equal to 10. So acceleration equals 10 over 5, which will give us 2 meters per second squared.